In question 24 we are given a velocity time graph of a car over a 50-second period. And in part A, we are asked to work out the average acceleration during the 50 seconds, and we need to give the units of our answer. Well, we can see from the graph quite easily that over the 50 seconds we got up to a velocity of 30 meters per second. If we've got up to a speed of 30 meters per second in 50 seconds, that means that our average acceleration was going to be 30 divided by 50, which is 3 divided by 5, and to divide by 5 that's the same as dividing by 10, then multiplying by 2. So that's the same as 0.6. But what's the units for this? Well, essentially we've done meters per second, so meters divided by seconds, divided by seconds, because we've done our 30, which is in meters per seconds, divided that by seconds, so we've done meters per seconds, divided by seconds, so the units are going to be meters per second squared. So the units we want here are meters per second squared, and that's the answer to part A. If we now have a look at part B, we've been asked to estimate the time during this 50 seconds when the instantaneous acceleration equals the average acceleration. By instantaneous acceleration, we're referring to the gradient of the line at any particular point. So what I would first do is draw the chord from 0, 0 to 50, 30. This is essentially what we've done in part A. We've worked out the gradient of that chord, which is the average. Now we need to find the point or points on the line where the gradient of the line matches the gradient of that chord. To answer this question properly, you should be looking at drawing a tangent line at roughly where you think the gradients match. And we can see from the graph that that's between around 11 and 14. So any answer between 11 and 14 would suffice, but it's important that you have the chord and the tangent line on the graph.